Ever wondered what secrets lie within the stormy depths of Neptune? Picture a planet so distant and mysterious that its storms could hold the key to understanding cosmic weather patterns. Neptune's atmosphere is a turbulent dance of violent storms and swirling winds. But are these tempests a recent phenomenon or remnants of ancient weather? In this video, we're diving into the heart of Neptune's stormy secrets. We'll uncover whether these ferocious storms have been raging for billions of years, or if they're a more recent development. Are you ready to unravel the mysteries of Neptune and explore what makes its weather so extraordinary? Stick around to discover the truth behind Neptune's stormy facade. Don't forget to like the video and subscribe to our Small World channel to stay updated on this type of content. Neptune, the eighth and most distant planet in our solar system, is often referred to as the mysterious blue giant. Its mesmerizing blue hue isn't just for show. It's a direct result of methane gas in its atmosphere, which absorbs red light and reflects blue, giving Neptune its iconic appearance. But don't be fooled by its serene look. This gas giant is far from calm. With a mass 17 times that of Earth, Neptune is primarily composed of hydrogen, helium, and methane, creating a vast, swirling atmosphere that is anything but peaceful. Picture this: winds that blow at over 1,200 miles per hour, almost supersonic, whipping through the planet's upper atmosphere. Imagine standing in the midst of those winds. Well, if you could stand there, which you can't because Neptune lacks a solid surface. Now, let's dive a little deeper into what makes Neptune's atmosphere so unique. You might think of storms as a rare occurrence, a freak of nature, but on Neptune, they're a regular event. Unlike Earth, where storms come and go, Neptune's storms are persistent and more powerful than any we experience here. These violent storms are fueled by the planet's internal heat. Radiating more energy into space than it receives from the sun. Neptune is actually one of the coldest places in the solar system, with temperatures dropping to minus 373 degrees Fahrenheit. Yet, it's also a realm of immense energy. It's like a paradox wrapped in a mystery, a place so cold, yet with such powerful, violent storms. Why do these violent storms happen? And what makes Neptune so different from the other gas giants? Neptune's weather is a fascinating enigma, one that has puzzled scientists since its discovery. The planet's fast winds create immense dark spots, similar to Jupiter's famous Great Red Spot, but with their own twist. These storms, with their dark centers and swirling clouds, look like cosmic whirlpools. It's like watching a celestial ballet, but one that's deadly and unforgiving. And what's more, these storms aren't just random occurrences. They seem to have a rhythm, a pattern that suggests they've been happening for a long time. Could it be that Neptune has always been this stormy, or is there something else at play? This is where the story of Neptune's storms starts to get really interesting, as we delve into the first observations and discoveries that revealed the true nature of this distant planet's atmosphere. It all began in 1989 when NASA's Voyager 2 spacecraft made its historic flyby of Neptune, becoming the first, and so far, only, probe to get up close and personal with the distant planet. What it found was both astonishing and puzzling. A colossal dark vortex, now known as the Great Dark Spot, swirling in Neptune's atmosphere. This storm was about the size of Earth, with winds reaching up to 1,500 miles per hour. To put that in perspective, that's faster than the speed of sound. The Great Dark Spot was akin to Jupiter's Great Red Spot, but darker and more transient, hinting at a dynamic and turbulent atmosphere. It was a revelation that immediately sparked curiosity and raised questions about what could be driving such powerful phenomena on Neptune. Following Voyager 2's groundbreaking observations, the Hubble Space Telescope took over the baton, peering into Neptune's atmosphere with its sharp, clear vision. Hubble allowed scientists to monitor Neptune's atmospheric changes over time, and what they saw was nothing short of spectacular. The Great Dark Spot, which had been so prominent during Voyager's visit, disappeared, only to be replaced by other similar storms. This wasn't just a single, stable storm. Neptune's atmosphere was a churning, restless sea of violent storms that appeared and vanished over time. It's like Neptune's storms have a mind of their own, forming, disintegrating, and reforming, almost as if they're dancing to a cosmic rhythm that we're only beginning to understand. These early observations set the stage for decades of intrigue and study. Scientists wondered why these storms formed and disappeared in such a manner. Could they be seasonal, driven by changes in Neptune's orbit around the Sun? Or perhaps they were caused by deeper, internal processes within the planet itself. Each new discovery brought more questions, adding layers to the mystery. As Hubble continued to observe, it became clear that Neptune's atmosphere was not just stormy, but in a constant state of flux. This unpredictability makes Neptune a fascinating case study in atmospheric science, showing us just how dynamic and complex the weather can be on other worlds. But what fuels these violent storms? Are they a recent phenomenon, or have they been raging for billions of years? The discovery of Neptune's storms brought with it a wave of questions, with one standing out above the rest. Are these violent storms a recent phenomenon, or have they been swirling in Neptune's atmosphere for billions of years? The truth is, Neptune's stormy nature could be as old as the planet itself. Some scientists believe that these storms are fueled by Neptune's internal heat. Despite its great distance from the Sun, Neptune radiates more heat than it receives, suggesting that something inside the planet is driving these powerful storms. Imagine a cauldron of gas, constantly boiling and churning, releasing energy that fuels these immense weather patterns. But what could be causing this internal heat, and why is it so powerful? There are theories that external forces might also play a role in shaping Neptune's storms. Solar winds, those streams of charged particles that flow from the Sun, might interact with Neptune's magnetic field and atmosphere, adding to the chaos. If solar winds can stir up activity on planets closer to the Sun, why not Neptune? This theory adds another layer to the mystery: the interplay between external cosmic forces and the internal dynamics of a gas giant. The lack of a solid surface on Neptune means that these storms don't just crash and burn like on Earth. Instead, they can linger, swirling for years, maybe even centuries. The sheer longevity of these storms raises intriguing questions about the mechanics of Neptune's atmosphere. As scientists continue to study Neptune, they're piecing together clues that hint at ancient storms, possibly even more violent than those observed today. The planet's intense weather patterns could be remnants of its formation, a celestial echo from billions of years ago. Picture ancient storms, the likes of which we can hardly imagine, raging across Neptune's skies, shaping its atmosphere, and perhaps even influencing its magnetic field. Understanding these storms isn't just about solving a cosmic puzzle. It's about unlocking the secrets of Neptune's past, present, and future. Could these storms be a window into the early solar system, or are they a sign of something more, something we've yet to understand? Recent technological advancements have given scientists new tools to peer into Neptune's stormy atmosphere, leading to some truly fascinating discoveries. With the help of powerful telescopes like the Hubble Space Telescope and data from other space probes, astronomers have been able to track the life cycle of Neptune's storms more closely than ever before. They've observed that these storms seem to come and go, almost as if Neptune's atmosphere is playing a cosmic game of hide and seek. One day, a giant storm might dominate the planet's atmosphere, and the next, it could vanish without a trace. This raises questions about the nature of these storms. Why do they appear so suddenly, and what causes them to dissipate just as quickly? In some recent studies, astronomers have even suggested that these storms might be much older than previously thought, possibly even dating back to Neptune's early days. Imagine storms that have been brewing for billions of years, shifting in size and intensity, shaping Neptune's weather patterns over eons. This idea opens up a new realm of possibilities for understanding not only Neptune's atmosphere, but also the atmospheres of other gas giants and exoplanets. These discoveries hint that Neptune might be harboring more secrets about the early solar system than we ever imagined, with its violent storms acting as guardians of ancient knowledge. The dynamic nature of these storms has also led scientists to explore the possibility that they might be driven by deeper, more complex mechanisms. Could there be unknown processes happening within Neptune's core that trigger these storms? Or perhaps interactions between Neptune's magnetic field and its atmosphere play a role in these meteorological phenomena? The continuous observation of Neptune's atmosphere has become a priority, as each new storm that appears and disappears offers a fresh opportunity to learn more about the planet's mysterious nature. As scientists unravel the details of these recent observations, it's clear that Neptune is not just another gas giant. It's a planet of intrigue, full of dynamic and possibly ancient storm systems that continue to challenge our understanding of planetary atmospheres. As we've uncovered today, Neptune's storms are more than just atmospheric anomalies. They are a window into the planet's complex and dynamic nature. These violent tempests could be ancient relics of Neptune's formation or signs of an ongoing, tumultuous weather system. The more we learn about these cosmic storms, the better we understand not just Neptune, but also the broader mechanisms that drive atmospheric phenomena across the solar system and beyond. Curious about how these revelations fit into our broader understanding of the universe? If you found Neptune's stormy secrets as intriguing as we did, give this video a thumbs up, share it with fellow explorers, and subscribe to stay updated on our latest discoveries. For those eager to dive even deeper, don't miss our previous video, where we tackled the question, is the universe expanding faster than we think? Click here to continue your cosmic journey and keep exploring the mysteries of the cosmos with us.